Okay, so this will require, I think, a little bit of background. Learning about asymptotes, that's kind of a big deal in this situation. So we talked about what a rational function is. I want to remind you again what a rational function is. It's a ratio of polynomials, and then the denominator has to have a degree of at least 1. What that means is the denominator has to have an x in it. It has to, okay? It can't just have a number in it, then it's not going to be a rational function anymore, okay? So let's just do like one example. F of x, what do? You take a polynomial, let's say x squared minus 1. That's a good polynomial. The numerator can be any degree, so it could just be a number, or it could be something kind of like that. Okay, that's just an example. There's an infinite number of examples you could come up with that. Okay, so first of all, I want to review some college algebra type material and what a vertical asymptote is. So a vertical asymptote in a rational function is going to occur where it's undefined. Okay, where is a fraction undefined? What makes a fraction undefined? 0 in the denominator, right? Okay, so that's kind of the key. So what you would do if you want to find a equation of a vertical asymptote is you just look at the bottom, and a lot of times you can do this in your head. You just set it equal to 0. What would make that 0? 1, okay? Yeah, so you would get x equals 1 would be the equation of your vertical asymptote, okay? A couple of things that you guys want to remember too, I'm just going to kind of remind you at the side. If you have x equals 1, the way you graph x equals 1 is that's just a vertical line that goes through the x-axis, okay? What if you have y equals 1? What does that look like? It's that way. So you want to make sure you know the difference between the two. That's important. So if you had y equals 1, that would go like that. So vertical asymptotes are going to be x equals something, okay? That's what that is, okay? Now, what I want to do on this is, I'm going to put this in the calculator. You don't have to put this in the calculator. Go ahead. Yeah. What's that? I can't hear you. I'm sorry. Not on this one. Okay, because if x is negative 1, you would have something that's defined. You're talking about on this one, yeah. Yeah, this one up here, you'd have 2 asymptotes. You'd have negative 1 and 1. Okay. All right, let's put this in the calculator and just see what this looks like. If we'd put this in like this, we'd have 1 divided by, then you'd have parentheses x minus 1. Okay, put that in. And what you'll see is most of the calculators don't show the asymptote, but you can tell it's there. Okay, so what's happening is when x is 1, you have a big break in the graph. And what's going on is there's a vertical asymptote there. And what happens is anytime that you have a graph with a vertical asymptote, the graph is always going to do this. It's either going to turn up and go to infinity, or it's going to turn down and go to negative infinity. That's a guarantee. And that's important that you know that, is once you see you have an asymptote, that'll help you to understand how the limit's going to work around that asymptote. So that's how that goes. Okay, let's do the next one. So what you want to do with this is, does it look like the denominator factors? Yeah, let's factor it and see what happens. Okay, so we'll go ahead and do that. So the first term is going to be x. So you have x and x. The last term is going to be 12. So you have all these possibilities. You have 1 times 12, 2 times 6, 3 times 4. Which one's right? 2 and 6. How come? Because you can make it equal to 4. Exactly. Okay, they're 4 apart. So that's no good. That's no good. That is. Okay, now when you're looking at your signs, it's got to go like this. Plus 6 minus 2, because 6 minus 2 is 4. Okay, like that. Okay? So nothing cancels out. That's important. Nothing cancels out. So in your head, what would make that equal to 0, that factor? Positive 2, right? What would make this 0? Negative 6. And you can do that in your head most of the time, but if you can't, then just do this. Okay, just write down those two, set them equal to 0, and solve the equation. You know, you can add 2 to both sides, whatever you need to do. So x equals 2 would be an asymptote. And same thing here. But most of the time you're just going to do that in your head. So the two asymptotes are x equals 2, x equals -6. Okay? And if you put that in the graphing calculator, I'm going to do just one more of these on the calculator here. This one would look like this. You'd have 2x plus 3. Whoops, I got to put it in y equals. So this would go like this. You'd have parentheses 2x plus 3. And then divide by the denominator looks like x squared plus 4x minus 12. Okay, just to show you what it looks like. Okay, so you're going to find there's two asymptotes. Okay, you see the two asymptotes? Okay, one of them is x equals -6. That's this one right here. The other one is x equals 2. Okay, and that's going to tell you something about the limit. That's what we're getting to, but we're not quite there yet. Okay, okay, let's look at this next one here. So again, the numerator does not factor. How does that denominator factor? X plus 4, x minus 4, right. That's the difference of two squares. So you do that, and you do this. Now watch this carefully, because the thing is on this one is, if something cancels out, then you're left with this. So you only have one vertical asymptote on this problem. So the thing is, don't just factor the denominator, see if something cancels out. So now you have x minus 4 equals 0, so x equals 4 would be the asymptote. You wouldn't see two asymptotes on that one, you'd see one. That's it, okay? So that's kind of the idea. Okay, let's do this example 3, and then we'll take a break. And we're going to use the calculator on this to kind of help us understand something. Okay, so let's get our calculators. Let's all do this on the calculator together, because I want to show you kind of what happens on this one. So in your head, where is the vertical asymptote on this problem? 2. X equals 2. Okay, let's go ahead and start by doing this. Just go ahead on the graph I gave you. When you do a vertical asymptote, just label it by dashed lines like that. So that's there. That needs to be on your graph. And then let's use the graphing calculator to do the rest. So I'm going to do 1 divided by, and make sure you have parentheses, then x minus 2. Okay, now what I want to do on this is just get a few points. Okay, and if you're drawing an accurate graph on this, this is what I recommend that you do. Just go to second graph to get a table of values and just see if you can find a couple of good points. Okay, like for instance, here's a good point right there. You've got 1, -1. That's a nice point. You have 0, about -0.5. And then another good point looks like is 3, 1, like that. Just get enough points. Another good point is 4.5, because all we're going to do on this is just sort of do a sketch. So you can get those values by looking at your table if you want to. And then the rest of it we're just going to sketch. Okay? So if you sketch this, it's going to kind of go like this. Anytime you have a vertical asymptote, the graph is either going to turn down or it's going to turn up. And then this thing never touches the asymptote, it just gets close to it. Okay? And then this thing right here kind of does something like that. All right? And then this part of the graph turns up to infinity and kind of goes like that. So that's the idea. Okay? So one thing that's real important for you as a student is that once you establish you have a vertical asymptote, you know one of the two things is going to happen. It's either going to go to infinity or negative infinity. Okay? All right. Now we're going to trace this out. First of all, when x is 2, what happens when x is equal to 2 in this problem? You're undefined. Okay, let's fill out this chart. Now this chart we're going to fill out with our graphing calculator like we were doing last time. So the way I showed you to do this in the last class is use your trace button. Make it easy. Just type trace and put in the first value, 1.9. Okay, that's going to give me -10. Okay, repeat it. Do trace. Now get a little closer to 2. 1.99. that gives negative 100. Okay, do it one more time. Trace 1.999. So you see what's happened. So what I'm wanting you to see is, as you're getting closer to 2, what's happening to y? It's just going way down there, right? So if I added another 9 in, that's just going to make it further down, isn't it? That's the idea. I want you to see that. Now let's go this way. Let's start with 2.1. And if we trace it 2.1, that's 10. Then we're going to close in on the other side. So if I do 2.01, that's going to give 100. And then the next one's going to be 1,000. You kind of predict it. So what's happening as we get closer to 2? What's happening to that graph? It's getting bigger and bigger forever. Okay, that's why it works this way, is asymptotes always work that way. So that's the idea. So if we're going to do the limit, which is what we ultimately want to do on this, now let's review kind of what we were doing. First of all, what kind of limit is this one? It's the 2 with the negative. What does that tell you? The left-hand limit, right? Like we talked about that in last class. So a left-hand limit, what you're doing is you're going to approach the asymptote from the left. Okay, so where is this function going? It's going to negative infinity, okay, forever. Now, you really can say two things. You could say the limit does not exist, because a limit only exists if it has a finite answer. But the way I'm going to teach you to do this is go ahead and tell me where it's going. So it's going to negative infinity. That's like that, okay? Now, do your right-hand limit. This one is a right-hand limit because of the plus sign. And if you do that, where's that one going? That goes to infinity. Good. Okay? Now, what is the meaning of just x approaches 2? What do we call that limit? Two-sided. Okay? So remember, we said a two-sided limit, you have to do both at the same time. So do they both go to the same place, or do they go to different places? They go to different places. So the limit does not exist. So you always just abbreviate that DNE like that. So that's how that works out. Okay? That's the idea. And it will always work that way around an asymptote. Now there's other possibilities. You could have both of them going to infinity, or you could have both of them going to negative infinity. Okay? All right, let's go ahead and break here till 20 after. Just to show you another way that asymptotes can work. Okay, so if you look at this one, in your head, what would make that denominator undefined? What number? Negative 3, right, okay. So x equals negative 3 is going to be where you're undefined, okay, because you would end up having 0 squared, right? Okay, so one thing you're going to have is, on your chart here, let's go ahead and fill that out as undefined like that, all right? Then we're going to do this on the graphing calculator, and I want to do this visually before we get into doing this without having to use our calculator, okay? Because calculator is a great tool. So let's put it in, and let's put in the numerator in parentheses. So we have x minus 1, and then divided by, and then new parenthesis, x plus 3, and then you can just put your second power button in like that and graph that. Now what's going to happen on this one, it's going to, remember I said if you have an asymptote, the graph's either going to go to infinity or negative infinity. There's all kinds of different combinations, so I'm going to graph this now, and it looks like what's happening is around the asymptote, what's happening? It's going down, okay? So let's go ahead and just do a trace on this. Let's start, see what I'm doing is I'm going to the left of negative 3. So I'm going to start like by just doing trace negative 3.1. And if your trace button didn't work, and you might want to see me after class, because that's sometimes your calculator's not set up right, so that's negative 410. Then what I'm doing is I'm just getting closer to the asymptote. So now I do negative 3.01. That's just getting closer. So that's getting to be a smaller number, 40,100 like that. And then one more time, let's do negative 3.001. And that's going to be 400,000, or I don't even know how many decimals that's got, negative 4001000. So the point is, what's happening? The closer you get to the asymptote, what's that number doing? It's getting smaller, right? Okay, so that's what we're going to have. Now, let's go this way, okay? Let's trace starting at negative 2.9. That's actually a little bit to the right of negative 3. So if I do negative 2.9, trace on that, let's see what we get there. That's going to be, looks like negative 390. And then if we do 2.99, whoops, negative 2.99, be careful there. All right, that's going to be negative 39900, and then one more time. Okay, so that's negative 3999000, like that. Okay, so you guys get the point, right? Hopefully, okay? Because we're not going to do this after this example. I just want to show you what's going on. So when we do a graph, let's do this like this. So we're just going to draw a rough graph on this. You want to go to negative 3, and you want to go ahead and draw your vertical asymptote through negative 3, like that. Now I'm going to see if I got any good points on here. So what I like to do a lot of times is go second graph to get that table to come out. Then I just try to find a few good points. Like one good point is negative 4, negative 5. Okay, like that. That looks like a good point. We have a point 1, 0. That's a good one. Negative 2, negative 3. And if you get just some sort of nice simple points, then you can just sketch the rest. Okay, so what's happening on this problem basically is it's doing something kind of like this. And it really approaches that x-axis. And it does this, and then it does something kind of like this. So the rest of it, you just kind of draw a sketch like that. Okay, so the whole point of this is to give you an understanding of how asymptotes work with the help of technology. Okay? All right, so let's see what we can do. Okay, what are you doing on this first limit, left or right? Left-hand limit, okay? So what that means is we're going to just look at the left of the asymptote. Okay, where's this graph going? Now, what's the y value? Negative infinity, good. Okay, we're going to negative 3, but when we're doing a limit, we're looking at the y value. So we would just say negative infinity, right? Okay, now do the right-hand limit. Okay, where's that going? Same thing, okay? So we would say that answer is negative infinity. How about the two-sided limit? Are they both going to the same place? Absolutely, so that's going to be negative infinity, that's it. Okay, so see, that's a possibility. These things, the thing I want you guys to understand is once you have a vertical asymptote, you know that it's either going to go to infinity or negative infinity. There's no other thing that can happen. That's the way asymptotes work. Okay, it's just the way the arithmetic works. Okay, so let's go to the next page. And what my goal on this now is, it's easy to do this with a graphing calculator. I mean, you can tell easily what the answer is. I want to do these without a calculator. Okay, so what you have to learn as a student is, first of all, I'm doing a limit of a rational function. If I have a rational function, you probably have a vertical asymptote. Not always, but a lot of times you do. If you have a vertical asymptote, the answer to these problems, every problem on this page, is either going to be infinity, negative infinity, or does not exist. That's the only possibilities that you're going to have. Nothing else is possible, and that's important. So, if you look at this thing right here, this function right here, what is the vertical asymptote on this problem? X equals 9, right? That's where you're undefined. Okay, so what we're going to do is we're going to figure out, since that's an asymptote, the left-hand limit can either be infinity or negative infinity, nothing else. The right-hand limit, same thing. The does not exist is a possibility for the two-sided limit. So here's what you do. All right, so what you're going to do, since it's a left-hand limit, give me a number that's less than 9, that's close to it. 8's good enough, too. You don't have to use decimals unless you want to. So let's just let x be equal to 8, okay? Keep it simple, okay? And plug it in. So where you see x, put in 8. So you'd have 8 plus 4 over 8 minus 9, okay? So that's going to give you 12 over negative 1. That's a negative answer, okay? You know what that means the answer to the problem is? Negative infinity. It's not negative 12, it's negative infinity. What we did is we figured out that it's a negative answer. When you're to the left of that graph, it's a negative answer. So that means it's going to turn down the closer it gets to the asymptote. Does that make sense? That's all you got to do, okay? All right, the next one is a right-hand limit. So what kind of number would you probably like to use?
Above 9?
Above it. What's a good number above 9? 10. Let's keep it simple. X equals 10. So we just do 10 plus 4 over 10 minus 9. So that looks like 14 over 1. So is the answer positive infinity or negative infinity?
Positive.
There you go. See, that's all there is to it. Okay? Now, what do you think the two-sided limit would be? On one side, it's going to negative infinity. The other side, it's going to infinity. What's that going to tell you? That it does not exist. Good. Okay, that's the idea. If they both go to the same place, then that would be the answer. Okay, everybody with me there? Okay, all right. You don't have to have a calculator to do this. It's just easy arithmetic. Okay, the next one. Okay, we have again a vertical asymptote at x equals 3. So see, the thing on this is you have to understand that I'm doing the limit around an asymptote. If I was doing this limit as x approaches 2, you would just plug it in and you would just get a number. But we're interested in an asymptote. So since this is a left-hand limit, what should I use? Something like 2, okay? So we have a vertical asymptote at x equals 3. Plug it in. So you're going to have 2 over 2 minus 3 to the second power. Okay, so you have 2 over negative 1 to the second. That's 2 over 1. What's the answer? Positive infinity. Okay, now I'll tell you what I do on a problem like this. And this is also, if you want to make this even quicker and able to do this faster, if you square something, what happens? You get a positive. So that denominator is always going to be positive. It always will be. So all you got to worry about is the numerator on this problem, really, when you do that. Okay? Yep. Yeah, absolutely. That just means that the denominator is set. That's positive without a doubt. Whatever the numerator is going to determine where it goes. Okay, so this is a right-hand limit. So let's use like 4. So if we use x equals 4, we'd have 4 over 4 minus 3 to the second. That's a positive number. You don't have to work it out. It's just if you see it's positive, then what's the answer? Good, positive infinity. Okay. How about the two-sided limit? What's that? Same thing, right? Okay. If the left and right go to the same place, then that's the answer to the two-sided limit. Okay. All right. Is that logical? Okay. Go ahead and crunch out the next two on your own. Now that number 2, I gave you a third power, so just crunch out the details. Okay, so let's keep working on it if you're in the middle of it. I'm going to go ahead and do this number 1. So on the left-hand limit, what's a good number to use on this first one? Like 4 would be a good one. Okay, so we could say 1 over 4 minus 5. Okay, what's the answer? Positive or negative? Negative. Okay, it doesn't matter. Only matters that it's negative. So that means that should be going to negative infinity. Now that's a vertical asymptote. Be careful, if I gave you the same problem, but I said x approaches 4, then it's not infinity anymore. This is just how it behaves around the asymptote. Okay, what's a good number to use on the right-hand limit? 6. Let's use 6. 1 over 6 minus 5. Is that positive or negative? Positive. So you can do that in your head. Okay, what's the two-sided limit's answer? Does not exist. Good. Okay, you end up having one going down, one going up. Okay, they're going different directions. Okay, problem number 2. What's a good number to use for the left-hand limit for negative 1? Negative 2 is what I'd do. So we have negative 2 minus 2 over negative 2 plus 1 to the third. Now what I do on this is the numerator is negative, right? That's negative 4. You can go ahead and crunch it out if you want to. The denominator is negative 1 to the third. What is a negative number to the third power? That's negative. So you have a positive number, don't you? Okay, so what's the answer? Positive infinity. Okay, see what I mean? Okay, be careful with your arithmetic. Okay, what's a good number to use for the right-hand limit at negative 1? I'd go with 0. So we'll just do 0 minus 2 over 0 plus 1 to the third. Okay, and the way I'm going to do this is the numerator is negative, correct? What's the denominator? It's positive, right? What's a negative divided by a positive? Negative. So that means the answer is negative infinity. Okay? That's all you're doing is figuring out the sign, plus or minus. Okay? What's the two-sided limits answer? Does not exist because they're different. Okay? That's it. Okay? So that's how you do it. All right? No graphing required. All right. Is everybody okay with what I just did there? Okay? All right. So next thing we're going to look at is kind of what happens when you have a hole in the graph. And you got to be kind of cautious about this, so I'm going to do a graph on this one. So if you look at this function, first thing I'm going to do is we're going to factor the numerator and the denominator. So we want to definitely go through and get the factoring taken care of on this one then, okay? All right, so go ahead and let's get the factoring in the numerator done. Okay, so we're going to have x times x. For 6, what would be the best number to use? 1 and 6 or 2 and 3? 2 and 3, because 2 and 3 are 1 apart. And that middle term is negative 1. Okay, 2 times 3, 6. How do you make a 2 and 3 add up to negative 1?
Negative 2.
Careful. Negative 3 plus 2, okay. All right, so we got that. And then the denominator, that's the difference of 2 squares. You need to see that automatically. That one is x plus 3, x minus 3. Okay, now watch this carefully, because what happens is when something cancels, that's not a vertical asymptote. Okay, what that is that is a hole in the graph. Okay, the function is undefined at 3, so there's going to be a little hole in the graph on there. It's not an asymptote. The one that's left over is a vertical asymptote. So what you would have here is x equals negative 3 is your vertical asymptote. The other one's a hole. Okay, that's real important, okay? So if something cancels out, don't fall for that being an asymptote. It's not an asymptote. It's just a little bubble, okay? Graph's undefined there. Does that make sense? Okay, now we're going to do a graph on this on our calculator. So let's go ahead and do this. We have a vertical asymptote at x equals negative 3. So we're going to go ahead and get that drawn on there, okay? And the next thing is, let's get our calculator out. Okay, let's put this one in. And you go back to you can either put in the original or you can put in what was left. It'll be the same thing, okay? So what we're going to have on this is, let's go ahead and just put in the original, because there is something I want you to see on this. Although if you put in x plus 2 over x plus 3, it'll give essentially the same graph, with one exception. So let's see, we have x to the second minus x minus 6, and then divide by x squared minus 9. So I think you should probably only see one asymptote on there. You won't see the whole, but I'll talk about where that is. Okay, and all we're going to do on this is just get a real rough graph on this. So I'm not even going to get any values. I'm just going to kind of have you do something kind of like this. So just draw something kind of like that, and then draw something kind of like this. It doesn't have to be perfect, just kind of get a rough idea, okay? Now, what I'm going to do is we have a hole is at x equals 3, okay? Why? Because that's the one that canceled out. Okay, so what you're going to have is when you go to 3, you're going to have a little bubble there. You're undefined right there. Okay, you guys, if you took finite, did you ever learn about this some? Okay, usually you do. Whether you remember it, I don't know, but that's the way rational functions work. So now we're ready to do the limit. Since we're in calculus, we're really talking about the limit. Okay, so let's kind of watch this real carefully. Now, what happens to this graph when x is negative 3? What's happening? What's special about this graph when x is negative 3? You have a vertical asymptote, right? So that means when you do a limit around a vertical asymptote, the answer is either going to be infinity or a negative infinity, or does not exist if it's a two-sided limit, okay? Well, it's pretty easy to do on this. What we could do is, this is really the same thing as just x plus 2 over x plus 3. So you can tell on this one, the left-hand limit, what's the answer to the left-hand limit on this one? It's going to positive infinity, isn't it? Okay, all right. If you weren't doing a graph, then what you could do is you could just take a number a little bit to the left of -3. And if you did that, you could use like -4. You could say -4 squared, -6, -4 squared minus 9. If you did that, you would get a positive number. I'm not going to do the details. I just want you to understand that's what would happen, okay, like we learned a few minutes ago. Okay, looking at the graph, what does it look like the right-hand limit is going to be around -3? Where's that going? Negative infinity. Good. Okay, no doubt. Okay, and you could do this like this. You could take a number a little bit to the right of -3, like -2. And you don't have to write this down. I'm just trying to remind you that without a graphing calculator, you could work that out and you'd get a negative answer. Yes?
Can you plug that number in our other variable?
Yes, that's even better. Yeah, and that's what I'm going to do on the next problem. What he's saying is, since this canceled out, why don't we just plug the number in here? And that's the smart way to do it. Is just do it that way because it's easier. That's what I do. Okay? All right. Now this next one is, this is saying the limit at -3. So what's the answer to the two-sided limit? Yeah, that does not exist, okay, without a doubt. Okay, so we got that. All right. Okay, now the next limits we're looking at 3. We're looking at x is 3. What is happening to this graph when x equals 3? You have a hole, right? And the thing is with this is, let's see if this will work. Is the two-sided limit going to exist here? Are they going to the same place? Are my fingers coming together? Absolutely. That two-sided limit is going to exist on this. So what you have to do with this one is, now we've got the cancellation. Really all we got to do is just do the limit as x goes 3 to the left. And since we've already canceled that out, let's just work with x plus 2 over x plus 3. Okay? See, what I was doing on that is, you know, we can just go ahead and work with the one that cancels. You could have done that on the last problems too, okay? So let's do that. Well, let's just plug it in and see what happens. If you plug it in, you're going to get 5 plus 2. Why am I doing a 5? I know what I think I'm thinking to what the answer is going to be. So that's 3 plus 2 over 3 plus 3. So that looks like that is 5 over 6. Okay, so that limit is 5/6. Okay, and the thing is that the reason that I plugged in 3 is because it's a hole. Okay, the thing on that is you're going to get an answer on that one. That's not an asymptote, so that's why we plugged that in. Okay, next one we're going to do the same thing. We're going to plug in the 3 again. If you do the right hand limit, you're going to get the same thing anyway. So if you're doing the limit from the right hand side of 3, you just do the same thing. You just do 3 plus 2 over 3 plus 3. So you still get 5/6. Okay? So what's the answer to the two-sided limit? 5/6 also. Okay? The thing that sometimes students get confused on this a little bit is this was an asymptote. When you have a vertical asymptote, what are the answers going to have to be around a vertical asymptote? What do they have to be? Negative infinity or infinity, right? Okay? If you're at a hole, that's not the case. Okay? It's not going to go to infinity. It's going to be some number. Okay, and what you're doing on this is really a 0 over 0 limit, so just plug it in. Anytime you have a hole, the two-sided limit's going to go the same place on a rational function. It's always going to be that way, okay? All right, is there any questions about that? Now, part of what we're doing, like in a business calculus class, is we'll start doing a lot of applications with business, and rational functions have a lot of application to them, as do polynomials. We want to kind of get comfortable with learning how the functions behave and how limits tie in. Okay, so on the next page, what we do now is we look at a limit at infinity, which means that we're now going to look at something like a limit as x goes to infinity. We're going to see what's happening to the graph as we go infinitely to the right or infinitely to the left. Okay, so I'm going to review this. Hopefully this is review. If it isn't, it's pretty easy to catch on. is rational functions sometimes have what's called a horizontal asymptote. Okay, it's going to be some sort of a horizontal line. So I'm going to go through and teach you kind of the rules. You may have learned this in a college algebra class. This is generally something we teach. Okay, so basically I tried to kind of show you everything that's important. We talked about vertical asymptotes. A deleted point is really a hole. I call it usually a hole. Okay, and the thing on this is, like this example down here that I had, okay, the one that cancels is the hole. So you would say you have a hole at x equals -2. The one that's left over is the vertical asymptote. So you'd have a vertical asymptote at x equals -5. Okay, everybody with me on that? Whatever cancels is a hole in the graph. Okay, the one that isn't is the vertical asymptote. So there's a set of rules that you learn that's real simple on a rational function. Is if the degree of the numerator is smaller than the degree of the denominator, then your horizontal asymptote's y equals 0. And what that means is it's just the x-axis. The x-axis is a horizontal asymptote. And we'll talk about what this means with functions in just a minute here. That's one possibility. And let's write down an example of that. An example of that would be f of x equals x to the second minus 1 over x to the third plus x plus 2. Okay, so from your background, you need to know what a degree is. The degree of the numerator is the highest exponent there is. That's 2, right? What's the degree of the bottom? 3. Since 2 is smaller than 3, that means that that's the horizontal asymptote. Okay, and we'll talk about what that means in just a minute. Second possibility is this. Okay, if the degree of the numerator is equal to the degree of the denominator, then the answer's staring you right in the face. I'm going to give you an example on this. Let's say that you have g of x equals 2x to the second minus 1 over 3x to the second plus x plus 2. Okay, so here's the point. All right, what's the degree of the numerator? 2, highest power. What's the degree of the denominator? 2. They are the same. So the answer is right there, 2/3. It's the ratio of those numbers right there. Okay, so that would end up being, that's what I'm saying, a leading coefficient is the number in front of the highest power. Okay, so that would be what your horizontal asymptote is y equals 2/3. Okay, and then the last thing that can happen is if the degree of the numerator is bigger than the degree of the denominator, then we don't have a horizontal asymptote. Okay, that's the idea. Okay. So what this deals with calculus is how things are behaving at infinity. All right, so let's go through some specifics here and see if this makes sense to you. Okay, this is also stuff that's in the curriculum in finite math or college algebra. All right, let's see if we know degrees. All right, so tell me what the highest power of x is in the numerator. 1, okay? Okay, how about the highest power of x in the denominator? 1. Okay, so what you learn from this is anytime those degrees are the same, the answer is right here. It's just the ratio of those numbers. So that's 2/1, right? So you would end up getting y equals 2 like that. Okay, that's only happens when the degrees are the same. All right, so here's what you want to do on your graph is if you have a horizontal asymptote at y equals 2, you just graph that line y equals 2. So we go ahead and do that then, okay? Now, the other thing is, okay, the vertical asymptote is just the denominator. What's the vertical asymptote? What makes that undefined? 1. Okay, so what we're going to have on this also is we want to draw a vertical asymptote of x equals 1 like that. Okay? Now, we're going to do this on the graphing calculator just to kind of show you. This is another good example to kind of show you what's happening to the graph at infinity. So I'm going to put this one in the calculator here real quick. And you can do this along with me if you want to. Okay, so I'm going to clear that out, and let's put in numerator in parentheses, 2x plus 6, and then denominator x minus 1, and graph it like in the standard window. Okay? Now, what I'm going to have you do on this, we're not going to really make this super accurate or anything. What I want you to do is just kind of draw a graph kind of like this. We're just doing a sketch. It does something kind of like that. It looks like it goes through -3, and then it just kind of does something like this. All right, so what happens on this, and that's a rough sketch, is what's happening to this graph as x gets bigger and bigger and bigger. What's happening to that graph? It's leveling off, right? So it's basically leveling off at what number? 2. At 2. What happens to this graph as x gets smaller? It still levels off at 2. That's what a horizontal asymptote does, is it tells you what happens to the graph as you go forever to the right or left. So you would get your limits this way. Okay, so the idea would be the limit as x goes to -infinity. That just means we go forever that way. Where does the graph go? It goes to 2. It never hits 2, but it gets very, very close to 2. That's the idea. Okay, and then the right-hand limit, same thing. Doesn't that also go to 2? That's it. Okay, so that's the idea. So now what we're doing is we're looking at a limit at infinity, or a limit at -infinity. And the horizontal asymptote is what it's all about. So you have to know how to take a rational function and know what its asymptotes are. Okay, does that make any sense? Okay, all right. So sometimes graphs are going to level off. Sometimes they're not going to. It depends. Okay, let's look at this next one. Okay. So the first thing is, this is kind of taking you through your thought process. Tell me what the degree of the numerator is. 1. Highest exponent, right? Tell me what the degree of the denominator is. 2. Okay. Now, anytime that the degree of the numerator is smaller than that, then it's y equals 0. Okay? That's a different case. If you look at the previous page, that's what I was showing you. Okay? So what I want you to do then is go ahead and just draw, it's really your x-axis. Y equals 0 is really the graph of the x-axis. So that is your horizontal asymptote, like that, okay? Now let's look at this for a minute. Let's consider the vertical asymptotes. Okay, you can factor that, right? So you want to go ahead and factor that, and then that will allow us to figure out what our vertical asymptotes are. So that factors as x plus 2 and x minus 2. Okay, like that. So what are there actually is 2 vertical asymptotes now. What are they? 2 and -2, right? Okay. So we're going to have a vertical asymptote at x equals -2, x equals 2. Okay, so go ahead and draw them. Okay, let's do that. So you're just going to have a vertical line through -2. And then 1 through 2 like that. Okay? And then what we're going to do on this is this. Now I'm going to go ahead and do the limits before I do the graph, because I know the answers to the limits. Okay? It's just like the last problem. If you have a horizontal asymptote, then these limits are going to be, that's going to go to 0. That's also going to go to 0. Okay? That's what you'll see on your graphing calculator. So once you establish that you have a horizontal asymptote, you know the answer to those. You see what I mean? Because that's what a horizontal asymptote is. It tells you how the graph behaves infinitely to the right or to the left. So those things are already established. We know it. Okay? That's what you think about when you look at a limit at infinity, is if there's a horizontal asymptote. Okay? All right, let's see what this graph looks like. So this one we just put in x over parentheses x squared minus 4. And we're just going to do a sketch, okay, just kind of a rough sketch on this. I'm not going to get any points, just kind of to get the idea. So it does something kind of like this. And then out, and this kind of behaves like that. and kind of like this. Okay, so that's the idea. So you can tell that left hand, if you're going to negative infinity, it goes to 0. If you're going to infinity, it goes to 0 also. So see, you don't have to do the graphs. It's just if you have a horizontal asymptote, that gives you the answer. Does that make sense? Okay, like the last problem was 2. That was the horizontal asymptote. Okay. Okay, let's look at this one. This one's the one that's a little tricky. Now, you want to make sure that they see if they have a hole in it or something. Let's go ahead and do this first of all. Okay, what's the degree of the numerator? 1. What's the degree of the denominator? 2. What does that tell you? Y equals 0 is the horizontal asymptote. Okay, without a doubt. Okay, so what are the answers to the limit? They are 0. Remember, this is a limit to go into negative infinity and go into infinity. That's it. That's how easy that is. Now, let's go ahead and do a little bit more with this, though. How do you factor 3x plus 3? I hadn't done this yet.
3x plus 1?
Yeah, right. You take a common factor of 3 out, right? So we want to go ahead and do that. So that would be 3 times x plus 1. Don't forget about common factors. And then if you do the bottom, you're going to have x and x, 2 and 1. How do the signs go to get that middle term? Okay, like that. Okay? All right. So let me see if you guys are kind of getting this now. Can you tell me in your head what the vertical asymptote is?
2.
Okay. What is this?
That cancels out.
That's a hole. And it cancels out, so it's a hole. That means the function, this function is undefined at 2 and negative 1. That's the asymptote, that's the hole. So what you have is you have a vertical asymptote at x equals 2, and then you have a hole at x equals negative 1. Okay? Right, so now we'll put this in the calculator. And when you do this, actually, if you do this in the calculator, you can actually, instead of putting the whole thing in, you can just put in what's left over, but you got to remember there's a hole there. So I'm just going to put in 3 over, whoops, I got to do a parenthesis, 3 over x minus 2. So we want to put that in like that. And then basically what I'm going to have you do is we know we have a vertical asymptote at x equals 2. Okay, we have a horizontal asymptote y equals 0. All right, and then I'm just going to graphing calculator, see what it looks like. Okay, so let's just do a sketch on this. It doesn't have to be perfect. Just kind of sketch the general shape and get as many good points as you want to like that. Now, the only thing that you got to remember on here is what's going to happen at negative 1. There's a little hole in it, right? Okay, so you got to make sure that you draw a little kind of a bubble right there. Okay, so you need to fix that. That won't come out on the calculator, but you need to know that it's there. Okay, so we had a hole at negative 1. So then you just draw that bubble in like that. Okay, but anyway, you can tell the limits are right. That's the whole point of me doing that on the graphing calculator, is to kind of prove to you that those limits are right. Okay, does that make sense to everybody? Okay. So I've shown you if you have a horizontal asymptote, that's how you can figure out what those limits are. Okay. All right, let's do this one. Okay. So here's the other thing that can happen. All right, tell me what the degree of the numerator is. Degree of denominator. Okay, so here's the thing. We don't have a horizontal asymptote. Anytime that happens, you do not have a horizontal asymptote. You have an asymptote that's going to slant. Now, we're only going to look at the one that's like a line, but you can have them that can be parabolas and all kinds of things like that. So I'm going to go into something in your background. You can kind of tell me if you remember this or not. We're going to divide 2x squared plus 6x minus 2. We're going to divide that by x plus 1. Now, sometimes students have been out of math so long they don't remember stuff like this. So we're going to do a long division problem, and the result of that is going to be what's called a slant asymptote. Okay? Did you guys learn synthetic division as well? Okay, you can also do synthetic. I'll do it both ways. It's up to you which way you do this. So what I'm going to do is long division. So what I'm doing is I'm doing 2x squared divided by x. Okay, one of those cancels out, leaving you 2x. This is another thing that you may have to review. Okay, and if you forget how to do stuff like it in your background, just go to YouTube and do searches, and you'll find, if you don't know how to divide algebraic polynomials, you can do a search on that and find all kinds of good stuff. Okay, then you multiply. 2x times x is positive 2x squared. 2x times 1 is positive 2x. Okay, like that. Okay, then you subtract these things. So I'm doing 2 minus 2 cancels. 6 minus 2 is 4x. Then I bring down the next number, I get a minus 2. Okay, it's just like long division if you're doing arithmetic. Then you start over again and you do this division. We divide this by this. So we do 4x divided by x. So that's equal to positive 4. So we put that up like that. Okay, then you multiply. 4 times x is positive 4x. Positive 4 times positive 1 is positive 4. Okay? Well, you're going to end up with a remainder. So when you subtract, 4 minus 4 is nothing. But this is really negative 2 minus 4, so that's negative 6. That's a remainder. Okay? Well, the slant asymptote is this. I'm not going to go through all the theory behind this, but the slant asymptote is whatever that result is.
So you don't take the 6 and put it up there?
No. I mean, what you learned how to do in an algebra class is you probably learned to do 2x plus 4 minus 6 over x plus 1. You put a remainder over the divisor. Okay? This part doesn't matter right there, because if x goes to infinity, this thing doesn't matter anymore. Okay? And I'm not going to take a lot of time to go through everything on this, but that's how that goes. Now, a lot of you have done synthetic division, right? Synthetic division is easier, so you might want to do it this way. So let's review this too. If you do synthetic division, you just write down the coefficients, 2, 6, and negative 2. And you divide by not 1, but negative 1. Okay, got to use the opposite number. Then synthetic goes like this. So you bring down the 2. Negative 1 times 2 is negative 2. Add, that's 4. Multiply, that's negative 4. And see, you get the same thing. See, that remainder of negative 6 is the same thing. Okay? But this right here is giving you the 2x plus 4. Okay, so you can do it that way if you want to. Okay, but you got to figure, it's good to know how to do this both ways, because you deal with this sometimes with rational functions. Okay, so here's what I'm going to have you do. We're going to graph this line. Okay, and we've been doing that. So it's got a y-intercept of 4, slope of 2. Let's go ahead and do that. Okay, so we just go up 4. And then if it has a slope of 2, we're going to go up 2 over 1, up 2 over 1. And then I'll have you just kind of draw like a line that goes through that. Now, I find that a lot of times students on this division have forgotten how to do it. So I did that pretty quickly, so that might be something that you may need to go through and review a little bit. Do searches online, synthetic division, long division. You can run through a little bit and get caught up on that if you need to. So now I'm going to go to my calculator. So I'm going to show you what happens on this one then. So let's see, I'm going to put in, let's see, 2x to the second plus 6x, and then, minus 2. And let's see, x plus 1. All right, and then graph that. And then we're just going to do a sketch. So what's going to happen, the asymptote's not going to come out, but I'm going to have you put that in just a minute. So what I'm going to do on this is, let's also do this on your graphing calculator. go to y equals, okay, that's the function that we just did, but also go down to y equals 2 and put in 2x plus 4. That's what we call the slant asymptote. So what that'll do is that'll draw a line through that like that, okay? Then let's graph it and kind of see what we got. Okay, so if you look at this, you see what's happening? You see how these things are getting close to each other? So what's happening is if you go to negative infinity, where is that graph going? Negative infinity, exactly. If you go to the right, see how those things are getting close? Well, where's the graph going? Positive infinity. Okay, so since you don't have a horizontal asymptote, you can guarantee that the graph is either going to go to infinity or negative infinity. Okay? The way that you'd have to figure that out if you didn't have a calculator is just plug in a big number and see if it was positive or negative. Okay? So anyway, if you do the graph on this, let's just sketch it. It'll be something kind of like this. The point is it gets kind of close to the asymptote. And on this side, it looks like maybe it does something kind of like this. Because you also have a vertical asymptote in here, and I need to have you guys put that in there too. So you have a vertical asymptote at x equals negative 1. And I forgot to have you put that in, so that goes like that. That's the reason why the graph's doing what it's doing. So it's going like that. It's kind of going like that. And so forth like that. It's just a really rough sketch like that. Okay? So, what is the answer to the limit as you go to negative infinity? Where's the graph going? Negative infinity. Good. How about as you go to infinity? That's it. Okay? That's how it goes. Okay? All right, so that's when you have a slant asymptote. Is there anything about that? How do you guys feel about division? Not good? Okay. And again, go to like YouTube, and if you look at my videos, I have college algebra videos on there too. So if you search around on there for long division, you'll find something on there. Okay. Factoring is another thing that you need to look at too. Okay, so to finish up today, I'm going to probably review one other thing that you learn in the college algebra class, okay, again, and this is when you have polynomials, okay? So what happens is, I want to kind of give you an example of an odd degree polynomial that has a positive leading coefficient, okay? So as an example, you could have something like f of x equals, say, like 2x to the third plus x minus 1 or something like that. Okay, the degree of this polynomial is odd. Okay, this number right here, we call this number in front of that highest power the leading coefficient, and it's positive. Now this is also stuff that we learn in finite math. Well, it turns out that if you have a polynomial and has an odd degree and the leading coefficient's positive, the graph does this. Okay, it kind of does that. Now what happens in between doesn't matter. The thing is, as you go to the right, the graph goes to infinity. As you go to the left, the graph goes to negative infinity. Is that familiar to some of you from finite or college algebra? Some of you, okay, all right. That's right, it's not hard to learn. That's the way that works. So I have that dancer. I always think of the poses of dancers when I teach this, okay? That's how it goes. Okay, now we got Mr. Disco Man. Here's another possibility. So if you have, say you have f of x equals negative x to the fifth plus 1. That's a polynomial, and again, it's an odd degree. Highest power is odd. The leading coefficient, which is the number in front, is negative. So if you don't know this vocabulary, leading coefficient is the number in front of the highest power. So it just goes like this. Okay, anytime you have a graph like that, that's what it does. So as you go to the left, you go up. As you go to the right, you go down. And that'll tell you how to do your limits on these problems. Okay? Right?
What was the first one again?
Like this. Okay? What you're looking at on this is the highest power is odd, and the number in front of that highest power is positive. So it goes like that dancer. Okay? The second one I was just doing is like this. Only thing is it reflected it. Like that, okay? Let's do an even. Okay, well, let's keep it simple. Let's say like we have 2x to the second plus x plus 1. Isn't that a parabola? What do parabolas do? Like this or like this, okay? So what this is that's an even, and that number in front is positive, so it just means the graph is going to look like this, like that dancer. Okay, that's it. Okay, and then the last case, we'll just kind of finish up here, will be this dancer. I tried to find a picture online of each dancer, okay? All right, so let's say that you had something like g of x equals negative x to the fourth minus x plus 2. I mean, all that matters is the highest power is even, and the number in front we call the leading coefficient's negative. That just means it's going to go like that, okay? So that's something that you want to review. It's not hard to learn if you haven't learned that in the past. But what we'll do with this next time is we just got a little bit more to finish up, is we'll use this to determine these limits, okay? So let's see, that'll wrap us up for today. Just a couple of things I want to remind you of.